We want to thank you for the teachers. We want to thank you for my friends, the teachers on board, the teacher who is going to teach. Father, we thank you because we are not worthy than those who have passed on, than those who are sick in hospitals, but it's all because of your sufficient grace in our lives. Father, we want to say thank you and we ask for your guidance as we start this lesson. May you guide us and may you keep reminding us what is going to be taught, oh God. We thank you for that teacher. May you bless him, give him the knowledge. Father, he cannot do without you. It's you alone that can guide him. Father, we thank you and we bless your name. In Jesus' name we pray and believe.
Amen. Thank you. Is your name Bob?
No.
Okay.
I'm Kachabe Faith.
Okay, maybe you rename your device right there. Okay. Thank you. Praise for this. As I said earlier, today we are proceeding with our topic of discussion, and that is pressure. We discussed a few concepts last Monday, probably for this week. And on board, we have a number of teachers. We have teacher Doreen, we have teacher Ronald, and others will come here with time. Okay, before we start off, I have a few stuff to talk about. I earlier this morning posted the requirements we need for this session, and for some minutes, I will request you or ask you whether you are able to access them. And then as well, I have posted the activities we are going to do this afternoon in our WhatsApp groups, and then in the Padlet, I will take you through that if you want to access them through Padlet. But we shall go through them right here as well as a class. But before we start off for today's work, let me request someone to take us through what we discussed on Monday. What we basically discussed in the previous. Someone will put up your hand. I have order here. Okay, Benjamin.
On Monday, we discussed about pressure and how to find the minimum and maximum pressure.
Okay. Pressure, minimum and maximum. Okay. Thank you. Any other contribution? Okay, Ruth. Ruth, you can proceed.
We learned how to find the mass of water in a container.
Okay. Are you able to take us through briefly what we did, briefly? A very few, Ruth. Anyone to take us through briefly? Okay, in the chat, Mchunguzi is saying we looked at minimum and maximum area. That is very good. Okay, I want us to remind ourselves because some concepts we dealt with are going to be needed right here. Okay, but before we go to that, I have posted the link to the Padlet, but again, we shall go through that right here after the review. Any other contribution? Friends, we should always remember what we discussed earlier. Okay, we looked at, of course, minimum and maximum area, and then we had different containers or boxes. And then as well, we looked at how we can find the volume of the content put in a box or container. And some friends here used the water. And for those who used the boxes, they used, I saw some people using books. That was very good. And on that note, I request your friends to at least take time and post your work after working out. Again, we shall go through how we post right here, but that is very important. Try to see what you have done during the lesson or even after, right there. But as well, that we looked at how we determine a mass of water for those of you who used water in a container to fill it at a given height. But briefly there, how did we obtain a mass given density and volume? Ruth?
Mass is equal to density times volume.
Okay, mass equals density times volume right there. And if your density is in kilogram per meter cubed, and then your volume is in meters cubed, then you can obtain your mass right there in kilograms. Okay, in the chart here I have Fiona. Fiona is saying this is her first lesson. Okay, yeah, okay. Now we shall take you through basically what you missed in the past 3 weeks. But welcome you here, and other friends who are new, welcome you all aboard. Okay, as I said earlier that we have about 2 activities to do this afternoon, and then the other one will be your assignment. That is now. Friends, I request you to mute, or maybe
Teacher Joseph,
okay.
It's Bobo. I think
Okay.
Faith should mute herself.
Yes, okay. But we shall as well do the needful, maybe if they forget. Okay. As I said earlier, I posted the work in the Padlet and then WhatsApp, and then what we need this afternoon. But before we go to the activities for this afternoon, how many were able to access what we need for this session? You can put up your hand if you accessed all. Remember, I posted the requirements in the morning. Okay, Daphne got them. Ruth. Okay, Ruth. Benjamin. Any other? Okay, Ruth as well. Okay, maybe other people. But on that note, I'm going to take you through through the Padlet to see what I posted right there. So I'm going to use the link, but first let me share my screen such that you see how I go through that right there. Okay, I go to the chat I posted the link already. It's there. Maybe I need to repost it for our friends who have just come in there. That is the link. So when you click on it, of course, we see that you can have this app downloaded from Google Play or App Store. And then you sign in using your email, and we shall be able to identify you by name. And if you're having a picture on your email, we shall be able to see that as well. So it will take you directly to where you need to post. Now, look out for today's work. So this is where you're going to be posting. So yesterday you did geography, but you haven't posted. Now, our column is going to be this one right here. 27th August. So that's where we shall be posting. So you'll be clicking on that plus sign, then you submit right there. So you can type, say, if you signed in as anonymous, meaning you didn't use your Gmail account, you can type, say, let me use Bob, Bob's work. Then you can say, please comment. Okay. And then if you took a picture, you click after cancel, there's that icon with mountains, then it will take you to the pictures. You choose any, say that it will load, and then the post icon will pop up. Then you can be able to post right there. But because I signed in already using my app, so my name is reflecting there from the Gmail. But if you didn't sign in, then you need to write there. Then any other person can be able to comment. I say thank you, and then right there you comment. So if you want to edit, you can click, look out for that upper right corner, the three dots there, click on them. Then you can delete, edit, and because for now I didn't intend to post, so I delete my post right there, but that is where I'm going to be posting. Now, let me take you to the board of teachers, where teachers always post. So I'll go back a little bit. Because that link I posted directs you right away to where you need to post. Okay, of course the page will load depending on the network, right there. Okay. So the first section is for timetables. I posted yesterday, the timetable yesterday. Monday we dealt with physics, Tuesday English, math, geography, and physics today, Friday. Now I am talking about now this column. This column is for teachers, this page. So don't post, or if you went through this page, then you need to click along senior 2 assignment handing badly. That's where you go to the other page now. But this afternoon, of course, as I said, I posted the requirements here, so you can look out for them. But when you click on them, you're able to access them right there. So let me request someone to read for us what we need this afternoon. Teacher Doreen, you help me pick anyone.
Okay, please. Somebody raise up the hand. Yes, Benjamin, go on.
In our discussion today, we shall need a uniform cubicle container, for example, a uniform cubicle food container or a jerry can, and a cubicle container, for example, a uniform cubicle cup, glass, bucket, or pail. Clean water, a common size dry battery cell, for example, Tiger Head, Panasonic, Hyper, or Durasonic. A set or long ruler. A set or long ruler, a scientific calculator. Note, please try to have these before the lesson. Stay well, stay safe.
Okay, thank you, Benjamin. So that was my post early this morning, considering the requirements we need. Now, if you didn't look at that, but of course we posted as well in the WhatsApp groups, we shall give you like 3 minutes to 4. You look out for those requirements right there. Look out for them. And if you have them already, get ready for the activities we are going to work out this afternoon. So the rest, please try to look out for this. You have about 4 minutes.
Yeah,
4
and
minutes.
if they get them, teacher Jose, they should wear a pass, and also they put it in the chat that me, I've gotten them.
Yes,
Somebody
that
should
will be
write
important.
that.
That will be very important right there. Okay, but of course I understand the scientific sheet is ready there, then a ruler. Then of course, water here we are talking about, okay, clean water, but as well you can have the normal tap water. And this side, of course, it is going to rain. So rainwater as well, that will work.
Somebody is shouting.
Can't tell like Sarah. I will slap you.
Please.
Faith, can you mute yourself? Let me mute her.
Yes, teacher Doreen.
I'm muting.
Do the needful.
I've muted.
Okay. Thank you. Now, a uniform Cuboid container, you should be careful right there because, okay, we shall talk about what a cuboid is in that case, but if you fail, look out for a 5-liter jerry can or 3-liter jerry can or 20-liter jerry can, any in your reach, right there. That can work. We shall talk about that as well. Then we need as well a uniform cylindrical container. Of course, uniform, I think we shall as well talk about what a uniform container looks like. And then, okay, you can have a cup. If you remember those plastic cups of nice, they are really important in this case. Or if you have your bucket as well, it can work right there. And then a common size D battery cell, like the cell you use in your torches. Yes, sometimes we call them the big battery cells right there. So basically those are what you need this afternoon. Okay, we have only 2 minutes so that we come to the activities. So I'm accessing all the work through the Padlet, meaning you can as well access them right there, but we stayed, this is a board for teachers to post. Okay, if you open through that, please don't post because you can easily see that only teachers are posting right there. But if you access through this page, then you'll be handing in through Senior 2 assignment handing Padlet, and you need to click where you see those nice folks, that picture right there, and it will take you, when you click on it, it will take you to their page, which you access through the link I posted in the chat right there. Of course, it will load. My network isn't good this afternoon because it is cloudy this side, but of course it will load. And look out for today's work for section, and today is 27th. August. So you'll be posting there. You click on the plus sign right there and then proceed. We will again go through that. Okay. Teacher Doreen, I think the 4
Yes,
minutes.
please.
We have exhausted the 4 minutes.
I
so
think,
we can
yeah,
go to, yes, we can go to the real concepts right here. So I'll come back to my post here and then click right there. So it is a PDF and you'll be able to access those nice pictures there and the stuff. Okay. Someone to read for us after lesson 2. Teacher, don't you help me
okay,
pick anyone?
to raise up the hand. If you want to read, please raise up your hand. Anybody? Yes, Arthur, go on, please.
I read from where?
Can you speak loudly?
After lesson 4. After lesson 4. Because we introduced already, the topic of discussion is pressure and we are proceeding. So this is our lesson 4. So after lesson 4, what do you see there?
At the end of this lesson, you should be able to determine pressure exerted by water in a uniform cuboid and cylindrical container, and also by a common size D battery cell.
Okay, thank you, Arthur. Then these are what we need this afternoon, but we already went through them. Maybe very first I'll read through them. Let me hope now you have your uniform cuboidal container, and this can be a uniform cuboidal container or food container, and or a jerry can in that case, if you fail to get the other. Okay, and then a uniform cylindrical container, and this can be a uniform cylindrical cup, glass, bucket, or pail. Now, before we proceed, someone to explain for us what uniform means. Or if one says that, get me a uniform container, what comes to your mind? Someone, a teacher, don't you help me choose right there.
Okay. Somebody? Any volunteer to give us that explanation? Somebody raise up the hand. Yes, Benjamin, go on.
It's like saying a container that has its sides equal.
All sides equal. That is very, very good.
Anybody else? Any other person?
Okay, if you don't have any other person, but anyway, the other explanation was very good, on point. Okay, then if one talks about a cube or a cuboid or cuboidal container, what comes to your mind? A cuboid, basically, a cuboid. Let's maintain that. What comes to your mind?
Yes, Miss Riza. Arnold, go on. Arnold, go on, please. I think network for Arnold is disturbing him.
Okay.
Yeah.
We can proceed to some other person.
Any other person? What do you understand by cuboid? Yes, Mariam, go on. They have some problems with network.
Oh, sorry. That's unfortunate. I understand it is going to rain.
It is
but,
already raining, but we can go on.
Okay. Let me check through the chat. Maybe you have answers there. Okay, a perfect cuboid. Okay, uniform or perfect. Okay, but we meant to say that the sizes are the same. Okay, a uniform or same sizes in that case. Uniform is the same as same in that case. But what is a cuboid in that case? That was my question. I remember we talked about it. Okay, one is say a box like that is Daphne. Okay, and then box like, but not all boxes are cuboidal. Okay, but by cuboid we mean to say that in that case, say for example, if you take the base area, okay, your length is different from the width in that case. That will give you a cuboidal container in that case. But if you're talking about a cube, then you have all the sizes with the same dimensions in that case, but it will be in that case in 3 dimensions. Okay, so that is what you need to look out right there. Then we need clean water. So because it is raining now, you can get the water or normal tap water in that case. Then a size D battery cell, we talked about that already. And we gave a number of them. And then a ruler, and then your scientific calculator. So I tried to give a few examples right there. Cuboidal container is the first one. Right there. And then we have a cylindrical. So you can easily see that they have the same sizes from the bottom moving upwards. And then you're having your battery cell right there. Okay. Now, the record there is to remind ourselves what we dealt with last time. Okay. Now let's head to today's activities. Okay, someone to read for us from the start right there. Anyone ready? You put up your hand. Tracy?
Yes, Tracy. Tracy, go on. Unmute yourself.
Oh, sorry.
Tracy, unmute yourself and continue.
Pressure exerted by water in a uniform cuboidal container. Activity 1. Look out for a uniform cuboidal container in your
Did we lose Tracy? I don't know. I don't seem to hear what she's saying. Maybe we hear from Tracy. Thank you. We hear from Daphne. Tracy has dropped right there. Daphne, please unmute and read for us.
Pressure exerted by water in a uniform cuboidal container. Task 1. Look out for a uniform cuboidal container in your region. For example, a uniform cuboidal food container or jerry can. Task 2. Measure and record the base length and width of your cuboidal container in centimeters. Convert these measurements to meters and hence calculate the base area of your container.
Okay,
Task
Daphne,
3.
a minute. So friends, you should now know what you already have. We explained very well how a cuboid will look like. It will be uniform. Like the picture you see right there under task 3, uniform from the bottom, okay? If you got that, that is very good. And if you did, maybe if you got a jerry can, now, we are going to estimate now a little bit. If you got a jerry can, now, if you look at maybe a 5-liter jerry can, it is not uniform from the bottom, okay? So in that case, we shall need to estimate as we move further, and I will guide you through that. But if you have a uniform container, then you can proceed as per task 2 to measure the base length. So using our picture right there, our base length will be Y or X, depending on the sizes. Remember, length will be the longer dimension in that case. And then the width. Base, you are talking about the bottom part of your container, okay? Measure the length and then width. We did this last Monday, so you should be able to do that very fast. So measure them using your ruler and record those dimensions in centimeters first to 1 decimal place. 1 decimal place. That is very important. And then after you convert them to meters, okay? In a minute, you should be able to do that. And if you are through, you can put up your hand. If you're through, you can put up your hand. We hear from you.
I think they're still working out.
Okay, no problem. Okay, who has finished to obtain the length and then width of the container?
They have not yet put their answer in the chat.
You can type in the chat or you can type your and answer. Or if it is okay with you, you can open your videos. If that is okay with you, you can be able to see what you're doing. And
I think they want us to see their videos.
Okay, if that is okay with them, they can open their videos. We see what they are doing. But anyway, if it is not okay with you, you can just post your answers. You can post your answers in the chat, or you can put up your hand and then submit. Okay, Teacher Doreen, you can help me.
Yes, please.
You can help me extract the registration link.
Okay.
Such that we as well get some feedback from our friends here.
Okay.
Yes. Okay, friends, how far have we moved? Remember, we did part of this work on Monday. So I should be able to measure very fast. And then, or maybe, how many were able to access uniform cuboidal containers and not jerry cans in this case? If you got them, you can put up your hand. Because we might be here when our friends only have jerry cans in this case. Okay, Arnold is saying the length is 18. Let me hope, Arnold, are these centimeters? I don't know. Let me hope they are exact. They are exact as 18 and then 13, in that case, centimeters. But if not, you should give to 1 decimal place. Okay, Muchunguzi is saying shoebox. Remember, you're going to put some water. So I think for a box, it will drain out. So we need something solid in that case. We dealt with the box last time on Monday. So this time you can have a jerry can at that point if you failed to get a container. Okay.
Teacher,
because
just
yes,
link there for registration.
Yes, but we shall come to that later. For now, let's first move. Because we already have the results, our friends have shared, a few of them have shared. Now let me hope, excuse me, let me hope other friends as well are proceeding in that case. Okay, if you have obtained your length and then width in centimeters to 1 decimal place, unless they are very exact as 18 or 13 or 22.
But of course, teachers say they can put 0.0.
Yes.
Yes. The
important.
Ruth, Muchunguzi, you can put 0.0 on your answer to bring out the concept of 1DP.
Yes, because this will be very important as we come to practicals. It will be very important. If you're using an instrument, then you maintain the decimal places are needed right there. Okay, convert them to meters. I saw Anna converted to meters, but again, I think your original values were 22 centimeters and then 9. So you missed out a point. If you're having your measurements in centimeters to 1 decimal place, then in meters, you'll be having 3 decimal places in that case. So you should take note. Maybe I need to give them an example right here. Let me use this. Say if you measured and you got maybe 15.3 centimeters, okay? Then to meters, to meters, what do you do? Sorry about my stuff right here. Hope you understand. Then to meters, you need to have 15.3 divided by 100. And this will give you a 0.153 in meters. That's why we are talking about one decimal place for centimeters, and then 3 decimal places in meters right there. So you should take note. Excuse me. Okay, with that, friends, we need to proceed. Someone read for us the next task. The next task right there.
Yes, Asimwe. Joanne, unmute yourself and go on.
Is it task 3?
Yes, please.
Place your container on a leveled surface and fill it with water to a certain height, h, and leave it to settle. Measure and record the height of water, h, in centimeters and convert it to meters thereafter.
Okay. Thank you. Let's pause a minute. Now, friends, get your water. Okay. If you're having a small container, put some water and measure that height. Same case like the way we did last time. You're measuring from after putting it on a leveled surface, it can be a table, it can be your floor at home. You can measure it. You can measure that height of water from the base moving upwards. Like the way you see the demonstration as per the diagram right there. Okay, let's proceed. Joanne, let's proceed.
Joanne has raised her hand. Is the one who is proceeding?
Yes, she's reading for us.
Take a clear photograph of your container together with water filled and post it under senior to assignment hand-in Padlet using the link below.
Yes, now this link is for those who might not be here, or those who didn't, or are not able to access the app or the link. Now, if someone went through WhatsApp and clicked onto that link, maybe I need to take them through that. Let me first stop sharing here. Okay, a minute right there. Okay, let me share my screen. If one went through WhatsApp, and then let me go to WhatsApp. Oh, sorry, okay, senior 2. Then you look out for the document that Mr. Dungu posted, or the one that I posted right here. When you click on it, and then click on that link right there, it will ask you to open or leave the WhatsApp and then open. When it opens, it will take you directly to the Padlet. So that is the instance for that link right there. But if you can access it easily, then that is okay. That is okay in that sense. Okay, Joanne, are you able to proceed now? Okay, she has read for us task 3. So friends as well, measure that height of water. Now, if you're using a jerry can, I said you can pause for a minute because there's a lot to talk about when it comes to a jerry can. Okay, so let me hope you have measured your height h in centimeters and you have recorded it in meters. Okay, task 4. Someone read for us task 4. Okay, before maybe task 4, someone in the chat is saying, yes, I don't understand. This is, okay. Faith, maybe you unmute and talk to us.
Where she doesn't understand very well.
Yes, maybe you can guide her from there because not understanding is very wide. Okay, Faith?
Okay, like when you're finding the height of water in a box, I don't understand how do you pour water in a box, or we just find some, okay, like a plastic cuboidal container.
Yes, okay. Thank you, Faith. Maybe I need to stress this. Last Monday, we dealt with a box, okay? It can be with papers, okay? But as well, we brought in a container. So it is called a container because it can contain or hold something, okay? Now you're talking about something solid, not a paper. You can talk about a plastic container. I gave some examples as per what we need under the requirements. So it can be a container where you put food or sauce, okay? Yes. In that sense, hope you get my point right there. We are not dealing with a box which is in paper form because of course water will drain out in that sense. So we say that you can have a container, okay? Maybe yes. Where you put your food, or if you fail, but it should be uniform in that case. But if you fail, you can use a jerrycan. And we say that you can have a 5-liter jerrycan, a 20-liter jerrycan, or 3-liter jerrycan. But you're going to come to jerrycans now, especially for task 4. Let me hope Faith is okay now. Okay, we have Emma. Emma, you have a concern? Emma, talk to us,
Excuse
please.
me, teacher. Excuse me, teacher. Yes, I have a simple question. And I think people dealing with pressure. I don't understand what is pressure all about.
Okay, Emma, let me
yet covered it.
Okay, Emma, your network isn't good, but I got your first statement. You're asking about pressure. I don't know whether you have just joined us. We have been here for the past 3 weeks, and we began from defining pressure, and we said pressure by definition is the force acting normally per unit area in that case. Yes, but if you look through the Padlet for senior 2, you can be able to go through the activities you have been doing. Okay, they will guide you through how far you have gone in that case. I know it will be very helpful right there. Does that answer your question, Emma?
Eric.
Okay. Okay, now you can lower if that is okay with you. Okay, someone read for us task 4. Task 4. Someone read for us.
Okay.
Power, you can unmute, but you don't have a mic. You can unmute.
Yes, I have another question. Yes, now we are dealing with pressure in container. Yes?
Okay.
Yes, we are dealing with pressure in containers. How is it?
How? I don't get your question, Emma.
I've unmuted, okay. We are dealing with pressure in containers. What is it all about? Please help me.
Okay. Emma, I request you first. It? Yes, I got your way. Now, Emma.
You don't get it.
I get you right, Emma. You can mute now.
I'm saying.
Okay. Emma, I got your question right. So of course, at school, we do define a lot of stuff, but with us here, we want to bring things in your life, okay? Because what Emma is asking is at the end, and I noted that as relevancy, is briefly asking, why are we studying this? So we shall come to that. I request you, Emma, to settle, okay? And just go through these activities as you do them. Then you'll get to know really what pressure is all about as we conclude these activities right there. Okay. As we move forward, Tracy, how I was reading for us. Okay. How you can... Yes, please.
I think Emma should also know that this time around we are dealing with activities of pressure in solids. You should be able to note that one also down. Yes.
Okay. How you can read for us? Task 4.
Hawa, unmute yourself, please. Inidi, are you able to unmute?
Yes, teacher. Task 4, using your measurements in task 2 and 3, calculate the volume of water in your container in cubic meters.
Okay. Now, if now you have, if now let me now go to let me now go to this. Okay, if now you have your length, L, okay, in meters, you have your width in meters, depending on what you have, and then your height in meters. How can we get volume? Right there. Someone? How do we get volume?
Somebody ready?
We are looking for volume of water now.
Yes,
okay.
Faith.
Volume of water is equals to length times width times height.
Okay. Now our volume right here will be the length times the width, and this will give you the base area. Okay, this will give you the base area, and then times height, and you're dealing with the height of water in that case. And then your value now will be in meters cubed, right there. Okay, let me hope you have done that.
I think Emma is having another contribution. Emma.
Okay.
Mutamba, do you have another contribution?
Yes.
Volume? Yes, please.
The same thing.
Okay.
The same thing.
Okay. Thank you, Emma. You can now mute yourself.
Times width times height.
Okay, very good. Thank you, Emma, for your contribution. Now, let me hope, friends, you have obtained that. Now, we come to our friends who used jerry cans, okay? Now, I want you to look at your jerry can. I want you to look at your jerry can. Is it really uniform? Does it look like the container we have right here from the base? Tracy, please, I request you to concentrate. The question is it uniform like the way that container is from the bottom, or it is curved a little bit? We need to hear from you. For those who are using jerry cans, in that case.
Yes, Emma. Unmute yourself.
Yes. The jerry can is somehow curved at the bottom.
Okay, it is curved. Then Arnold, unmute. Okay, Arnold is saying also it is curved. Now, if now you're able to feel, if you're able to feel that jerry can, it will be very important in that case. But if you don't have water to fill it, then you need to estimate now its volume. Because if it is a little bit curved, then you won't be able to measure the base length and then width it very well, okay? But if you can fill it, say for example, if you have your 5-liter jerry can, okay? Maybe let me take you back to this. If you have your 10-liter jerry can or 5-liter jerry can, and remember, we are talking about liters, okay? You're having a 5-liter, okay? 5 liters right there. But we need to ask ourselves, okay? What is the equivalence of 1 liter? 1 liter equals, someone to tell us?
Yes, Emma. Unmute yourself.
Yes, what I know is that 1 liter is equivalent to 1,000 cubic centimeters.
Okay.
1 liter is equivalent to 1,000 cubic meters.
Okay, Emma.
1 liter is equivalent. 1 liter is equivalent to 1,000 cubic centimeters.
Teacher Jose, have you had
1 liter is equivalent to 1,000 cubic centimeters.
Okay.
Okay, Teacher Doreen, thank you. I had dropped my network. It's
Yes,
terrible this side.
Emma is saying that it's equal to 1,000 cubic centimeters.
Yes, we said 1 liter is 1,000. Eh?
Yes.
1,000 cubic centimeters, right? Now, what of 1 liter will equal to how many cubic meters? How many are they?
Anybody to answer?
Anyone ready?
I think Mutamba is leading.
Okay. Emma, your hand is up. Do you want to say something?
I think his hand is just up. Anybody to tell us what 1 liter equals to in cubic meters?
Okay. In the chat, Anna is saying, okay, we have the answer right there. Anna gave a right answer right there.
True.
As
0.001 meters cubed.
Yes, 0.001. That's very right. Now, if you have a 5-liter jerry can now, what of 5 liters will be how many? That anyone to give us the answer?
How? Oh, how are you bringing a problem in our lesson?
Okay, we are using meters cubed. If you have 5 liters, remember we have this conversion already. Okay, how do we get the volume now in meters cubed? If you have a 5-liter jerry can.
Anybody to give us that query? You can raise up your hand, please, if you want to tell us your contribution. How can we change the 5 liters to
Emma?
cubic meters?
Emma?
We can change the 5 liters. Get the 5 liters we multiply by 1,000 cubic centimeters. 5,000 cubic centimeters.
Okay, that's when you use that conversion. But remember, we want our volume in cubic meters.
Thank you,
Ruth gave a right answer. What we do basically, we multiply 5 on both sides. We multiply 5 on both sides using that scale right there. So let me first remove this now. It's like having a 5 times 1 liter will be the same as having 5 times 0.001, and that will give us a 0.000 and then 5 meters cubed right there. So if you fill your 5-liter jerry can to full capacity, that will be your volume. Now, for our friends who used jerry cans, you know what to do. If you use the 10-liter jerry can, get 10 liter will now be 10 times 0.001, and that will give you 0.01 now. 1 meters cubed. So that will be the volume now you're going to use right there. If you need to note something, please note right there. But we need to move. We need to move to the other concept. Now, for our friends who used other containers uniform in that case, then you need to obtain volume, as we said earlier. Now, if you have someone to read for us task number 5, someone to read for us task number 5. Task number 5.
Yes, Joanne.
Task number 5. Using a convenient formula, find the mass of water M in your container if its density is 1,000 kilograms per cubic meter. Yes. Hence, find its weight W if acceleration due to gravity is 10 meters per
Anybody else to finish up? Thank you, Asimwe. Anybody to repeat for us? Yes, Faith? Faith, unmute yourself.
Using a convenient formula, find the mass of water M in your container if its density is 1,000 kilograms per cubic meters. Hence, find its weight in meters if acceleration due to gravity is equal is grams is equals to 10 million.
Okay. Maybe I didn't get her last statement, but I had something like grams. Friends, note that G doesn't mean grams, but that is acceleration due to gravity. Let me hope you looked at quantities. Okay, let me take you to this. What we need to note, first of all, we need to note that density, which is rho, equals mass out of volume. Okay, but we know the density of water as 1,000 kilograms per meter cubed, and then we have the volume now. So what you do, you cross multiply, okay, such that your M now, which is your mass, will equal to the density times the volume, right there. You know the density of water already? We gave it as 1,000 right there. And then the volume you have obtained. Now, the other note is weight, okay? Because to determine pressure, we need the force that quantity is exerting onto the table or ground, as we said. But as well, if you transform, because what you need to note here, very important to note, I understand you talked about it earlier, is that force equals mass and then times acceleration, right there, okay? Or this is written as MA, and this is given where A is newtons, sorry, where A is acceleration, where A is acceleration, and then M is mass, okay? And then the SI units for force. Who knows the SI units for force? Anyone? SI units for force? Anyone will call it? Pardon?
Somebody raise up the hand.
Or you can type in the chat if your network isn't good.
Faith is there.
Faith, unmute. Yes. Newtons. Yes, very good. Now, okay, Benjamin as well is saying newtons. Now, if you have, okay, the SI units right there of force will be newtons, capital there. Now, if our acceleration now becomes acceleration due to gravity, then we are talking about weight. Weight. And our weight right there will be now M times G, where G, please note, G is acceleration due to gravity, not grams. Acceleration due to gravity. If you're dealing with the weight, that is very important to note. Now, using the formula for mass above right there, we obtain the mass. We obtain the mass right there, okay, of water. Now, if we have mass right here, and then the acceleration due to gravity was given as 10, and then substitute and find the weight of water. Let me hope, friends, you're writing, because you're taking time such that we go through all this. So you have the mass of water, you have density and the volume, obtain mass. Then you want to obtain weight. Weight, if you know the mass of water, and then acceleration due to gravity, G is acceleration due to gravity, 92 grams, which was given as 10 meters per second squared. You substitute and find the weight right there. Not everything, because we shall need to submit right there. Any questions before we proceed? Okay, in the chat, Newton's, okay, we are talking about force. But as well, note that because weight is obtained from force as well, the SI units for G, the SI units for G, sorry, the SI units for weight, not to G, is weight. The SI units for weight are newtons as well, from the formula of force right there. Because acceleration due to gravity as well is an acceleration. So you should note that. Okay, we are moving away from this. Let me hope, friends, you have noted right there. But as well, we posted a registration link. So please attend to it if you're through, because we need to get your feedback right there. Okay, right there. Okay, teacher Doring has posted it once again, so attend to it. Okay, we have obtained the weight. Now, someone to read for us the questions, because we have spent a lot of time here because it was very important. Someone to read for us the weight, the questions, okay? Benjamin, please.
Given the base of your container, given the base area of your container and the weight of water as Wm, neglecting the weight of the container, how can you obtain the pressure exerted by the water in your container on the leveled surface?
Okay, right there. How can you obtain pressure? If you have weight, because we said weight is the same as force, only that acceleration becomes acceleration due to gravity. And then we have the area, the base area of the container. How can we obtain pressure in that case? Anyone to take us through how you obtain pressure? Because we discussed this earlier. You remember the formula for pressure? Was it our first lesson? Yes, we talked about the formula and then the SI units. How did we give the formula in that case? Okay, Charity. Charity, unmute. Charity, unmute. Your hand is up.
You can as well put it in the chat.
I don't seem to get you. Maybe you can type in the chat. Pardon? Maybe Charity, you can post in the chat. Gabriela, do you want to say something? Your mic is open.
The correct answer also.
Okay. Okay. Faith is saying force out of area. Very good. But now we are going to transform because now we have weight, okay? So now, simply our pressure now, which is P, will be now weight and then the base area, which we obtained already right there. So substitute and find your pressure in Newton per meter squared right there. So you should be able to substitute right there and then find the final answer as your pressure. Right
Also,
there.
Teacher Jose, they can also put in as Pascals.
Yes, very important. We talked about the other units for pressure as Pascals. That's very important as well to note. Okay, let me hope, friends, you're noting everything because you're going to post your work so you can look through it right there. Okay, that answers question 2. So you should be able to substitute right there and then proceed. The note we have there is very important. Take a clear photograph of your solutions. That's why we are telling you to note and post it under senior 2 assignment and in Padlet. Very right there. We shall take you through again then. Or you can as well post a PowerPoint presentation. Okay. The IT gurus as well, you can do that because it is very important. Now, that takes us to our second activity. This is very simple, very short as well. So I expect not to spend a lot of time here. Okay, someone to read for us what we have at this page. Someone ready? You put up your hand. Okay, Emma.
Pressure exerted by a common size D
Emma, your network isn't that good. Isn't that good? I don't know. Maybe you can hear from another person. Muchunguzi. Emma, sorry about that. Your network isn't good. Muchunguzi, please.
Pressure exerted by a common-sized battery cell. Task 1. Look out for a common-sized battery cell in your home or in your ridge. For example, Tiger Head, Panasonic Hyper, or Durasonic.
Okay. First, wait a minute. Chunguzi right there. Let me hope now you have your cells already. You know the sample you're talking about. You can easily look at them as well below here. Those are the sizes you're talking about right there. Those are the sizes you're talking about. Okay, let me hope you have them already right there. Okay, Uchunguzi, you can proceed to task 2.
Using a ruler and a negative terminal of a battery cell, measure the diameter of its base thrice and record them in the table as shown below.
Okay, a minute there, because we need to take our friends through what they need to do. Now, look at your battery cell. Look at your battery cell. Let me try to sketch it a little bit here, but don't mind about what I'm drawing really. But let me hope it is of that form. So at the top, if you put it on the surface like this to rest maybe on the table, Below here is your negative terminal. And when you look at it, it is labeled. And then here where you have a node right there, that is the positive terminal right there. So expect your battery to be in that form if you try to rest it on the table of a surface. But now they're asking us to measure diameter. How do we measure diameter? And why do we need all the three? Now let me first erase this such that now I look at the bottom part of it, or the negative terminal, like this. So I look at it from the bottom or negative terminal, okay? So we are going to measure our diameter, getting a ruler, and then measure from that point, okay, from the circumference right there and there, okay? Note that diameter, okay? If they are, I'm just giving an example. If they are 2, because you need to measure. If they are 2 centimeters, sorry, 3.2 centimeters, you note. Then the second time, we are measuring thrice or 3 times. The second time, you can now measure from there to that point. But through the center, if this is your center, try to estimate the center. And if say this is your D1, then think about D2. For D2, you can get it as maybe 3.1. I'm just giving an example, okay? Then look out for another, maybe through that. You maintain the center right there, and then you get your D3. Your D3 as maybe 3.2 centimeters, okay? After getting the 3 diameters, then you need to record them in the table right there. So let me hope you have done that. Anyone confused? If you're confused, then you tell us, but that is what we expect you to do. If you're confused, you put up your hand, and that is what we expect you to have right there. Are we set to go? Benjamin, unmute.
So I'm confused on how to measure the diameters, the 3 diameters.
Okay. Benjamin, I said, let me go back here. Okay. Let me first remove this. I said, look at the bottom part. Okay? We looked at the negative terminal. We say that if your battery is like this, okay, then you have a node just above there. So that is the positive terminal. And then below, that is the negative terminal. So when you rest it on the table, you expect it to be seated or resting like that, okay? Now, look at this bottom part. Look at this bottom part right there. Make it to face you such that you have it now as this, okay? I'm trying to sketch, don't mind about my sketches. So what you do, get your ruler, okay? Get your ruler and then put your 0 mark maybe somewhere there, and then through the center, measure up to that point, okay? From that point up to there, measure that length in centimeters. That will give you your D1. If you get it as, I'm just giving an example. Mine won't be exact, okay? But I want you to practice that. Maybe 3.2 centimeters, okay? That will be diameter 1. Now look out for other routes. But again, you're putting your ruler right there, okay? Your 0 mark right there. And then through the center, you measure up to there. But through the same, you estimate the center you used the last time. So if you measure that, and maybe it is your D2 as 3.1, I'm just giving an example. Centimeters right there, don't mind about the handwriting. Then look out for another, but estimate the center. Again, that will be a 0 mark right there above, and then up to there. And then you obtain maybe that as well as D3. And this can be as well maybe 3.2 centimeters right there. So that is what we need to do. That is what we need to do right there. Let me hope, Benjamin, now you're okay. Is that okay?
Yeah, it's okay. Thank you.
All right. Now, let me hope, friends, you have done that. Someone has a concern? Okay, no. In the chat, okay, Benjamin, I have answered you. Let me hope other friends are okay now. Okay, we are going to move from this point now. Let me hope you have measured your diameters and you have filled the table. You need to draw that table, redraw that table, and fill it very well. Okay. Then let's go back. Let's go back there. Someone read for us task 3. Someone read for us task 3. You put up your hand. Okay, Faith, proceed.
Your measurements in task 2 above. Find the average diameter of the battery cell.
Okay. Oh, you have a checker there. Okay, read that checker, very important.
How do you obtain average diameter using the measurements in task 2 above?
Oh, okay, that is a question for you to think. Probing question. How can we measure average diameter? Anyone ready to discuss for us how we measure? Remember, average is the same as mean. Okay, if you looked at mean, Benjamin, unmute.
We add all the 3 diameters, then divide by 3.
Yes, if you need maybe average, which is D, get the diameters, the 3 of them you have obtained, divide by their number. They are 3. So you divide by 3. Okay. Get your diameters, fill them, plus the second one, plus the third one, divide by 3. If they were 2, you would add 2, divide by 2. That is the average. We get the total over the number of items. Okay. Very important right there to note. Let me hope you have noted that. Remember, friends, we note because we need to submit after this right there. Okay, Faith as well is saying we add the sum, we find the sum of diameters, then total number, yes, there are 3, very right there. Okay, now task 4, want to read for us task 4? Anyone, you put up your hand. Tracy.
Using average diameter, D in task 3 above, obtain the radius R of the base of battery cell. Record this radius R in centimeters and then convert it to meters.
Okay, before you head to questions, how do we get, given the diameter now, the other average D, that's what we are going to use. If you have your average D, how do you get radius? If you have the D, but we got D from 1, then 2, then 3 over 3. Now we need a radius. Don't mind, friends. We need the radius R. How do you get radius? Anyone ready? If you have diameter, Emma? Emma?
You have the diameter like D1 plus D2 plus D3, then divide by 3. To get the radius, you divide the whole thing by 2.
Yes, or simply after getting your D, that value right there, then your radius R will be the D divided by 2. Okay, if you already have them in centimeters, yes, in centimeters, then after getting your radius in centimeters, you convert to meters by dividing by 100. Right there. Okay, let me hope, friends, you're doing that. You're doing that. After getting your diameter, average diameter or mean diameter, find the radius by dividing the D obtained by 2. After getting them in centimeters, you convert to meters. We know already how we convert to meters. Okay, we are moving away from this very fast to go back to our questions now. Someone to read for us the questions. Question 1. Anyone ready? Read for us question 1. Let's hear from Tash right now. Please unmute, Fifi. Fifi, unmute and read for us.
Question 1. If the battery cell is placed such that its negative terminal is in contact with a leveled surface or table, and using the information obtained in the task above, how can you obtain the area in meters squared obtained by the battery cell? Take pi 22 over 7.
Okay, a minute there, Fifi. Okay, we want to know how can you obtain the area in meters squared occupied by the battery cell if it is resting on the table or flat surface in that sense. Anyone to take us through? I don't know whether Fifi and Emma, you left your hands up or you want to submit.
Yes, I'm there.
Okay.
Yes, I'm there.
Emma?
I want to submit.
Okay, please go on.
Find its area. If you want to find its area, then it means when you have already got your radius, it means the area is pi r squared. If you want to find its area, it means it is pi r squared.
Yes, pi r, then squared, okay?
Squared.
We know the radius. We know the radius already.
Yes.
Okay. And then our pi has been given as 22 out of 7. Then substitute the radius you got and then square it. Okay. Now remember we converted our radius to meters. Okay. Now the answer you'll be having here will be in meters squared right there. Let me hope, friends, you're noting right there. We have a few minutes.
Yeah.
Yes, in just 5 minutes, we shall be uploading. So right away, you're going to shift from this, so that we go back such that we go back there. So after finding area, then question 2. Someone read for us question 2.
For sure, he needs to get some praise. Yes, please.
Proceed. Faith, are you on call? Your hand is up. Okay, Emma. Emma, can read for us?
Yes.
Question 2.
Given that the acceleration due to gravity G is 10 meters per second squared, and using the mass of one of the batteries below measured in grams.
Okay.
Check, did you find any batteries below?
Okay, a minute there, Emma. What? A minute before what? Now, friends, we want to hear from you. Were you able to get any of those batteries? If you did, you please talk to us. If you are able to obtain maybe a Tiger Head, a Panasonic, Ultrasonic, were you able to get any? Friends, we need to hear from you because we need to guide you on what you need to do. Did anyone get any of the 3? Okay, Faith is saying yes. Faith is saying yes. Benjamin, what do you want to say?
I said I got one of those.
Okay. Now, friends, if you got one of them, just know that a Tiger Head, the mass of a Tiger Head, the first one, right there. Okay, Charity.
Get any? Charity? Yes. You did not get any?
Above here. Mass of Tiger Head is 61.5 a gram. Okay, so there you need to convert to kilograms. And how do we convert to kilograms? We divide by 1,000. Okay, then if you got a Panasonic, a mass of Panasonic is 77.0 grams. All those measurements there are in grams. Okay, we have a digital beam balance right there. That's what we use to measure mass. So if you have a Panasonic, take the mass in grams as 77.0 and convert to kilograms right there. Then lastly, if you have a Durasonic, its mass is 63.5 grams as well, convert to kilograms right there. Okay, as we proceed, Emma, are you proceeding?
Yes, I'm proceeding. What is the pressure exerted by your battery cell in Newton meters per second, Newton meters per meter squared onto the leveled surface of the leveled surface or table?
Okay, you're pressing your battery cell onto a surface, level surface, or table. They want to obtain the pressure exerted by that battery cell. So that is what we need for our final task for activity 2. So remember we say that for pressure, if you go back here a little bit, pressure right there, we say that from that, okay, by this time we have weight, which is W over A. We have obtained the base area of the battery. And now we know the mass now, depending on the battery you have. Convert that mass to kilograms, then you'll be having mass to have weight, mass times acceleration due to gravity G, and then over the base area in that case of the battery. And that will give you the pressure exerted by the battery cell right there. Very important to note as we move forward. Lastly, we have about 6 minutes here. So that the last minutes are for you to upload the work. Let me hope you have been doing with us because it was very important right there. Okay, we shall move away from this.
Faith, do you have a question? Your hand is up.
Actually, I really don't understand that statement where Sir had said that, okay, like finding the pressure exerted by the cell on a surface, like leveled surface.
Oh, so you want to know how they calculate. Do you know the formula for finding pressure?
Yes.
Can you tell it to me?
Force out of area.
Yes, force out of area. Okay. So now, depending on what we had, okay.
Yes.
We have found the area, okay, the base area. Hope you now know how to get the base area.
Yeah.
Yes, after getting the base area, then you put the force. The force we are going to put there, the weight. Okay. We are going to put the weight of that cell. Okay. Do you know how we get the weight? The formula for finding weight? Faith, do you know the formula for finding weight?
No.
Okay, so the formula for finding weight, it is supposed to be mass times acceleration due to gravity. Supposed to remember that, okay? Force equals to mass times acceleration due to gravity. So the mass, you put that mass of the dry cell, the one which you obtained, okay?
Yes.
And then the acceleration due to gravity is always a constant and it is equal to 10 meters per second squared. So you substitute the formula and then you come out with a pressure exerted by that cell. Is it fine now?
Yes, madam.
Okay, is there anybody with another question? Anybody who wants to ask something? If you have a question, raise up the hand, please. Yes, go on.
I think I skipped quiet.
Yes, Joanne. Joanne, please, you have a question? Joanne, you have, yes, Benjamin? Benjamin, unmute yourself and talk to us.
I was asking to confirm about the question of finding the area where we had to use pi r squared. Is it that we have to use the 22 out of 7 times the average area? The average radius, I mean.
Yeah, because we know that we got the diameter, we got the average diameter, and then from there we got the radius of that cell, the base area, the radius of the radius.
Thank you.
So you use the pi of 22/7.
Yes, then the average radius.
Yes, please.
Thank you.
Yes, Faith. Your hand is up. Coletti? Okay.
Excuse me, madam.
Yes, please, Bob.
I am Faith Kachabe.
Faith, I know you.
Yeah. But then you muted me and then I like you can't see me when I raise my hand to contribute.
Oh, let me see you. Let me see you here. You're not.
Really?
Yes, you're not muted. I'm saying that's why I was able to see you.
Okay, thank you.
Yes, I think, did you get the question very well, or I put the work there?
Yes. You can put, I didn't get.
Okay, let me try to put the work. Let me try to share also.
Teacher Doreen?
Yes, please, Teacher Joseph.
Sorry, friends, the drop proof. My network this afternoon is terrible because of the weather. I request you to assist. Okay, that's okay. I don't know whether you had proceeded.
Yeah, we are just finishing up to some things like questions, and then we wanted some work again.
Okay. Had we gone through this?
We're just going to share that.
Okay. Friends, we had done the other. Sorry about that. I had some hiccups, network, as you know. But we have done the activities already. So what we need to do is to note right there. We are taking their photographs of our work and we are posting in the Padlet. The link is there. Maybe teacher Doreen, you can help me repost that link, or I can get it again right here.
Okay, I can try to trace it out and I put it there in the chat.
Okay, but as well, if you go to WhatsApp and access the document I posted there, when you click in it, you'll be able to go directly to where you need to post your work. Okay, now, do we have Emma here on call? Do we still have Emma?
Yes.
Okay, now Emma, because you asked a lot about pressure, read for us that take-home assignment. Take-home assignment.
Okay. Using your uniform cylindrical container filled with water to a height H, describe how you can determine pressure exerted by water in this container in Newton per meter squared.
Okay. Thank you, Emma.
Assumption container is negligible.
Okay. So I'm leaving you to try out the procedure because you already know how we use the we measured the volume for the first activity, and then for the second activity where we have a battery. Now, a battery, the procedure for a battery is a little bit similar to when you're having a cylindrical container, maybe a cup uniform from the bottom, okay? You're going to fill it with water to a given height, okay? and then try to detail for us how you can measure the pressure of that water. So that is your assignment. And at one point, maybe before Monday, we shall need to look at that assignment. Then Emma, proceed lastly to the relevance.
Relevance of these concepts. With these concepts, we are able to one, determine weight of bodies, 2, explain why a full container is heavier than a half-filled container, 3, obtain pressure exerted for bodies contact.
Okay. And did we do all those using the activities? Yes. Okay. If yes, then we have achieved what we wanted. And Emma, that answers your questions you had why we study pressure and stuff. But there's a question there, very important to note. Question? Read it, please.
Question. Please remember dispose of where all the materials used in this session.
Okay. Thank you, Emma, and thank you, friends, for attending this. Sorry, we had some network issues, but we are able to proceed. So moving forward, we expect you to do this work and then post it under senior 2, assignment turned in. Padlet, we went through that already. Maybe if I share my screen briefly, I'm going to use the link posted there. When I look through the chat, I click on that link. Directly, it will take me to the Padlet of senior 2 homework. Then I look out for day's work, 27. Look through. So right here, you tap on the plus sign, and then submit your work there. If you signed in as anonymous, where you have the title, type your name. But if you use your app and you signed in using the Gmail, you don't need to do that. Then you can post using the picture. After cancel, there's that icon. When you click on it, pictures will come. Then you click on them, it will upload. If there are many, they will upload. A post icon will pop up. Then you click post, and your work will be there. And you shall be able to comment right there. So those are the procedures to submit. Please do the needful right there. But this marks the end of our session this afternoon. We thank you for coming and attending. We thank Teacher Doreen, Teacher Ronald, and all the teachers who came in, and the students as well for attending. We meet probably over the weekend. That will be Saturday, as we go through the seminar in that case. Otherwise, I wish you all the best.
Excuse me, Mr. Joseph.
Yes, please.
Before you end.
Yes.
I am joining you for the first time, but like you're talking about WhatsApp discussion groups, can I have the numbers? Because I'm using a laptop.
Okay. Okay, Teacher Doreen, are you able to extract the link to senior 2? I don't seem to have the current one because the other streams are full. I don't seem to have the link to a new one. But that was, okay, you used the Bob anyway. Thank you, but are you able to access the Padlets?
No.
Click on that link. Click on that link we posted in the chat. Are you able to see that link?
Yes,
yes, click on that, and then we shall be posting all the updates there. And the WhatsApp link, I try to post it right there. So be checking under Padlet right there. okay? For any updates for now. Okay, Emma's hand is up. Friends, we need to end this. Emma?
Yes, I'm also confused on how to get the Padlet.
Okay, Emma, come to the chat, okay? Come to the chat. Look out for that link that Teacher Doreen posted. It has padlet.com. When you click on it, it will take you right away to the Padlets, okay? You don't need to do much. So yes, you'll be able to access all the work that you have done so far in the past 3 weeks right there. So make use of that app. It is very, very important right there. Okay, friends, if you don't have any other questions, I call it quits for now. We meet tomorrow. And please don't forget to post your work at least before the end of today. Otherwise, thank you for coming. Yes. We meet tomorrow or in the Padlets or WhatsApp. Anyway, please. Thank you.
Bye. Yeah.